Well, good afternoon, conference, from a rather dismal UK. Thanks very much, Ranjit, for inviting me to speak to the conference, and I'm only disappointed that I'm not able to be with you in person. But hopefully over the next few months we'll get to meet some of you as we roll out our plans in India. At Recycling Technologies, we're passionate about plastic. Plastic is a fantastic material, and hence its growth since the 1950s to over 322 million tonnes in 2015. And the projections are enormous, and quite rightly, because plastic actually has some enormous benefits for mankind and for the environment. It makes our transportation lighter and more fuel efficient. It actually keeps us safe in hospitals. It keeps food fresher for much, much longer. And so it has a wonderful narrative in terms of its benefits. Until that is that we come to the right-hand side of the slide and we see what happens to it at the end of its life. And sadly, the global position is dreadful. 40% of plastic is landfilled. 14% is just goes to energy from waste, which seems to be a shame for a great material like this. But when you think that 32% leaks out into the environment and creates scenarios that look a bit like this, then that really is something that we have to do something about. And we're very proud to be part of the new plastics economy. And one of the statistics which has been hugely emotional for us is actually that by 2050 there's a prediction that there'll be more plastic in the ocean by weight than fish. And that can't be allowed to happen. And at Recycling Technologies, we're passionate about making sure that that doesn't happen. And we think that we have a solution. Now, I have a manufacturing background, and so I recognize the value of mass production. If you wanted to add a lot of capacity very, very quickly, you need machines that you can mass produce. And so that's how we've addressed this problem. And we've designed a solution for this plastic waste, which is modular, which can be mass produced at very low cost, and then deployed to locations where the plastic already is. Now that might be waste recycling centres, which exist in many, many places. It may be beaches. It may be in areas where the plastic has simply been dumped. And so without creating logistical problems, we're able to take this machine, locate it on a flat surface, set the thing up and run it. It produces its own power, it produces its own fuel. And so it's a very standalone solution for this huge problem of plastic. And so it takes any kind of plastic, it thermally decomposes it, and then it takes out the contamination that's associated with plastic, which makes it a difficult material. It takes the chlorine out of PVC. It takes the fluorine out of PTFE. It takes out the fillers, it takes out the fire retardants, and so on and so forth. And what you're left with at the end is a clean hydrocarbon. We call it PLAX. And it's a range of hydrocarbons. It's a distribution of carbon chain lengths from waxes right the way through to naphthas. And we're able to take these materials and able to distill those into several fractions, and they can have multiple uses. But what fundamentally I'm excited about is that the predominant use of this material is to make more plastic. So where are we? Well, what we've actually done is we've gone from the science at the laboratory scale, and we've gone to a very large engineered scale, which is very close to the final machine that we want to produce. And you can see it here operating at our facility in Swindon. And it takes in horrible old plastics that we all recognize, whether they're laminates, whether they're food pouches, whether they're black material, whether they're engineered materials, the rigid plastics. All of these plastics are applicable, and they simply get shredded and then dried and then put into the chemistry set where that thermal decomposition takes place and the filtration of the products and then cooled down in a fractional process to actually produce the various grades of the material. What this enables is our vision, if you like, of the circular economy process for plastic. So you'll see in the lower half of this diagram, mechanical recycling. And it could be doing an enormous amount more than what it currently does. There's just simply not enough capacity for mechanically recycling of plastic, and I would encourage any economy around the world to be adding more to its mechanical recycling of this great material. But we recognise that there are even environmental limits, that the energy to mechanically recycle some plastics becomes prohibitive, and so ultimately you need a new technology. And that's where the top half of this diagram comes in, where we're able to take the stuff which is currently regarded as unrecyclable and turn it back into plaques, which can then go back to the polymer manufacturers and become more plastic, making plastic truly an entrant into the circular economy and preserving those ever so precious resources. Now, we also recognise that in some locations around the world, getting that material to a polymer manufacturer might not be the easiest thing to do logistically. And so we're quite clear that a lot of this material could also be used as fuels. It's a very low sulfur fuel, very suitable for marine applications or for power generation applications in appropriate engines. And so, what this enables is a fresh look, if you like, at plastic recycling. And we're delighted to be running one of the pioneer projects with the new plastics economy, which is actually looking to say, if you bring together the best technologies available in the world today, how much plastic could you actually recycle? And we think the answer is more than 90%, either mechanically or chemically. And so Project Lodestar, with a whole range of different contributors, and we're really grateful for the input from each of these companies, we've come up with this blueprint, if you like, from the plastics industry for the world to say, this is how plastic recycling should be done, can be done right now and going forwards. And so mechanical recycling is where you start, and what you can't mechanically recycle, then you chemically recycle to make sure that none of this great material needs to be left behind. And so this is a blueprint, is great, but what about a physical version of this? Well, we're indebted to the Scottish Government, who have precipitated a building of the very first of the Project Lodestar designs at a project which we now call Beacon, with reference again, of course, to the amount of plastic in the oceans and our increasing concern over that terrible environmental issue. And so Project Beacon is seeking to recycle more than 90% of the plastic arising from households in Perthshire by putting together a combination of the mechanical separation technologies and the chemical recycling, which is our machine, the RT7000. And so we're super proud to be part of what is potentially a game-changing approach to the way plastic is recycled, and a shifting of the expectations as to how much plastic can be recycled, and economically. And it's important that it is economically sound, because in my view, unless it actually makes money, then it will never gather enough momentum and enough legs, if you like, to actually really make a difference. And so the combination of it's commercially very attractive and it's mass producible has the opportunity here to create immense scale in very, very short periods of time. In fact, as a company, we have an ambition to install 10 million tonnes worth of recycling capacity in the next 10 years. And that might be an enormous task, but it's a task that we think that we can achieve through the power of mass production. And so, if you would like to join us on our journey, and we really hope that you do, and we're looking forward to meeting many of you in the coming weeks and months, and we were looking for people who want to participate with us as partners, as investors, as site owners, as people with plastic. If you want to get in touch with us, we'll be delighted to speak with you over the coming months. Thank you very much, and enjoy the rest of your conference.